Thank you very much. So, my name is Joonas Pylväinen, working as a product manager at OptoFidelity. So, a little bit about our company. So, OptoFidelity has been founded in Finland in 2005, so quite a while ago. And our focus has been on XR testing, so extended reality testing, including VR devices, but especially augmented reality devices, displays and headsets, for example. And we are a product house. We offer out-of-the-box metrology tools, but we also do have some custom projects that we have been doing on the side as well. So what we are offering, of course, is metrology solutions, but we have a long history also in advanced robotics. And complementing all of that, we of course have the software for our tools and then support and services. And at the moment, we are employing a bit more than 300 employees, and we have 3 different production sites in Finland, Estonia, and China. And currently, we are counting that we have over 9,000 different type of systems delivered into different industries as well, not just for the XR world. And now from the previous presentations, I already saw some waveguides and I saw diffractive gratings. So now talking about a bit more about the waveguide displays, let's say if they are made from diffractive gratings as well. So the challenge usually in them is that you have your perfect image from your projecting unit, let's say micro LED or laser-based scanning system. You input it into the in-coupling grating, then it travels through the expander grating, and finally from the out-coupling grating, it comes to the user's eye. And then your result is a bit off from what you were expecting. So instead of your perfect white field, you maybe getting a dark image and some bands. Could be color issues, could be luminance differences, or any sorts of image quality problems. But now then, going forward from the simple or single waveguide, the next issue, of course, is that when you are scaling up the production, here I have some sort of a basic production process of AR smart glasses. So with the manufacturing, the challenge will be that in the front end, where you have the master, you have the soft stamp, maybe nano imprinting that you are using, maybe some etching there. The processes are quite sensitive. Your process window is very narrow. You need a lot of control there, and you need to have all the causes and effects mapped out so you understand what's happening there. So due to the sensitivity, when you go to the back end, where you are maybe dicing the waveguides out of a wafer, or you are stacking multiple ones, or maybe doing some edge blackening on the side of the waveguide or some other process, you need the high sampling rate. So for the metrology. So you need high throughput and it needs to be cost effective as well. And that is the reason why in addition to our other image quality testers, and also we have a grading tester here, we are offering our new product called Production IQ, so production image quality measurement tool. So this is a quality control tool for metrology and aimed for pilot lines and manufacturing lines alike. And it measures all the critical to quality aspects of waveguide displays. So critical to quality being something that the user or the end user cares about, like uniformity, contrast, MTF, color uniformity, and that sort of things. And also, as you can see from the pictures here, it is modular and scalable, so you can have it as a standalone version as well, or part of a bigger system with multiple modules on them, or maybe integrated to an existing manufacturing line as well. So going a bit further to the actual sample support and the robotics of the tool, we are supporting now the eyesight measurement or mirror mode type of waveguides, meaning that the in-coupling is happening on the same side as the out-coupling of the light. And sample type here could be any type of waveguide display, so diffractive, reflective, holographic, polarization, holographic gratings, or anything like that. So input the light from one end, and you get the image out from the other end, basically. And the shape and size can be customized anywhere up to a 300 millimeter wafer if the samples have not been diced. Then on the pantoscopic tilt and phase wrap angle, both the instruments can be manually tuned, depending, of course, with the customer. We will do a study that what is actually the mechanical limit that we can go with the angles. For the robotics part, since this is meant for as a production tool and not the kind of R&D tool with a lot of flexible angles, we have been keeping mostly only the XYZ axis here. So we can still do iBox scans, and we can still do multiple inputs and adjust the Z height depending if the sample is stacked or not. And as I said, of course, in each case, an individual study is made for the mechanics that how the sample fits inside the tool. So for the measurement capabilities, I have here a couple of examples, not from an actual sample, but from the tool measuring or looking at the projector itself. So the maximum field of view is 80 by 60 degrees, and we have in-house standard analysis for the images. So either following the IEC standards or the ISO standards, for example, radiance, uniformity, efficiency, contrast, field of view. With the grayscale camera version and with the color version, there's also luminance, color uniformity, and chromaticity. And also in this case, the patterns and the size of the pattern is customizable. So it could be a clear reticle like here, showing the maximum field of view. It could be a checkerboard, maybe a denser checkerboard even, or slightly less dense. And then also a slanted edge reticle example here. And for the analysis part, we know and understand our customers that the standard analysis for the image quality, they are not always suitable for the use cases. So we do have an API for Python and MATLAB that could be used, or we can also help to implement the custom analysis. So kind of from the point of view that this could be considered as an image taking machine, and then the algorithm that post-processes the image for a number could be then anything that the user desires. Now, then the other part is that you could go with the singular tool, of course, but you could also have the case where we have the parallel modules here. So with the single tool, if we look at now that we are in a manufacturing environment, the cycle times and how we are using the time becomes more important. So with the single tool, there's always, you are loading a tray, you are doing the first measurement, let's say uniformity, then you do the second measurement, contrast, then you do the third measurement, let's say with the color filter, for example, then you unload the sample. And after that, the second sample is waiting all the time, and then you load it, and then you go to the measurements. So all these loads and unloads, they are basically non-value adding time for the production process. Of course, this depends how many samples you have in a tray. So it could be one sample or it could be 10 samples, but you still have basically this case that something is waiting for the measurement. Now with the parallel modules, let's say you have three identical ones. You could run one type of measurement in one of the modules, the second in the other one, and the third in the third one. So of course, what will happen is you still need to load and unload the samples. So the flow time of the sample through the system stays the same, but the cycle time will be faster as each time the sample is moving from one measurement to the other, it frees up the station for the next sample. So there are multiple samples going in parallel here. And this also gives an option into the future that if the image quality tester is not the only thing you want, maybe you want another type of tester there, maybe some customization inside the station. You could have multiple measurement cases here, and you only need to load from a single end of the tool, either the diced waveguides or the wafers that would then go through the whole system. And in short, that's basically the idea of the production IQ building on top of our existing R&D tool. And if you have any further questions, please do ask or visit our website for more details, or you can contact our sales as well. Thank you.